All right, so we are going to apply the Pythagorean theorem and its converse. So for the first problem, we're going to just review Pythagorean theorem. So what is the diagonal length of the screen? So we'll say this is a TV screen or a theater screen, more like it, 7 feet by 3 feet. The diagonal, what letter would we put with that? What variable? C. Okay, so we're going to do Pythagorean theorem. So as a refresher, you would have a squared plus b squared equals c squared. So I would plug in my numbers. So 7 and 3 can either be a or b, it doesn't matter. So 7 squared plus 3 squared equals c squared. And then I calculate.
49 squared plus 9 squared.
So we don't put the square anymore. So just 49 plus 9 equals c squared. And then add those together. So 58 equals c squared. And then I have one last step. Square root. What'd you get?
7.6.
Okay.
Is that right here?
So 7.6 equals c. All right, so we're going to use this. We're going to keep using this today, Pythagorean theorem. And we're going to add another formula in there, and that's called the distance formula. So this might be kind of small on your paper, so if you want to rewrite it. So the distance is one big square root, and it's x2 minus x1 squared plus y2 minus y1 squared. Okay, so these little 2's and 1's at the bottom of the variable, those don't mean square. That means your second x minus your first x. And then this means your second y minus your first y. So the little 2's at the top, those do mean squared, but the 2's and the 1's underneath your variable, those just mean like second x minus first x. And this looks a lot worse than it actually is. This really isn't that bad to do, even if it looks really like it's going to be a lot and difficult, okay? So the first problem is find the distance between points A and B and C and D to the nearest tenth. So I'm going to show you two different ways you could do this problem. So the first way we're going to do is the distance formula. So first thing I would do, so we're going to do the distance between A and B is you need to write your coordinates for A and B. So your coordinates for A are 2, 3. And then your coordinates for B are 6, 0. So that's your first step. And then you could go through and label them. You don't have to do this every time, but sometimes this is helpful at the beginning. So this is x1, y1, x2, y2. And then I'm going to plug them into that formula. So D equals square root. And then I'm going to take x2 minus x1. So 6 minus 2, parentheses squared. And then there's always a plus sign in the middle. And then y2 minus y1. So 0 minus 3 squared. Okay, so then I'm going to start simplifying that. So 6 minus 2 is 4. So 4 squared plus, and then 0 minus 3. So I'm going to keep that in parentheses, squared. Okay, so then I'm actually going to square them. So 4 squared, 16 plus negative 3 squared is positive 9. And then I'm going to add them together. So you get square root of 25, which equals 5.
Yeah, that's a lot.
Okay, so the other option you have, since these are pictures of triangles on the graph, is you could do Pythagorean theorem. So to find the distance between C and D, which would be, we would call that our C, we could find the other two sides of the triangle, the legs, and count them. and then do Pythagorean theorem. So if I count this leg, it is 2, and then this one is 6. And then I'm going to plug that into Pythagorean theorem. So I'm going to have 6 squared plus 2 squared equals c squared. So 36 plus 4 equals c squared. So 40 equals c squared, and then square root. So c would equal 6.3. Okay, so me personally, if I have a graph to look at that is made into a triangle, Pythagorean theorem is much faster and easier. So I'm going to choose that way if I have a triangle to look at. However, you don't always have a triangle. And then you would do distance formula. Okay, so we're going to practice this again on the next problem. So find the distances between points J and K and L and M. So let's write down our coordinates for J and K. So J is -4, 0, and K is 0, -3. Okay, so I'm going to plug those into my distance formula. So x2 minus x1, so 0 minus a -4. So now that happens to be a double negative because the the minus sign is already in the formula, and then my coordinate happens to be negative. And then I have a plus sign in the middle, and then -3 minus 0 squared. Okay, so then we're going to go through and simplify. So do your parentheses first. So 0 minus a -4 would be +4 squared plus -3 minus 0.
3 squared.
It would still be -3 squared. Okay, so 4 squared is 16 plus -3 squared, +9. So that equals 25, and the square root of 25 is 5. Okay, so I want you to write down the coordinates of L and M and go through the distance formula on your own. So you'll need to pause your video and go through that problem. All right, so my coordinates for L are 4, 0, and for M, they're 6, -3. So if I plug in my distance formula, I would have 6 minus 4 squared plus -3 minus 0 squared. So then I simplify, and that gives me 2 squared plus -3 squared. So that is 4 plus 9, which is the square root of 13, which equals 8.6, no, 3.6. 3.6. Okay? All right. Good, everybody? All right, the next thing we're going to look at is tell whether the given lengths could form a right triangle. Okay, so if I had 2x4s, which means like a piece of lumber, piece of wood, if I had 2x4s and I cut them to be like 7 inches long, 24 or 25 inches long, could you construct those 3 together to be a right triangle? So you couldn't always do that. Like they would have to be a certain ratio or a set of numbers in order to always make a right triangle. Does that make sense? Like you could make some kind of triangle with 3 boards, but it doesn't always mean it could be a right triangle. So what we're going to do is we're going to plug in all 3 numbers into Pythagorean theorem, and we're going to see if this does make a right triangle. So Really quickly though, we have to decide which one has to be C.
25.
So the longest side always has to be C. Okay, A and B can be switched around. They're interchangeable. It does not matter. So here we're going to have 7 squared plus 24 squared, and we're going to see if that equals 25 squared. So 7 squared is 49, and then 24 squared is what?
576.
576, and then 25 squared is 625. Okay, so next you would add 49 and 576. And does that equal 625? Yes. Okay, so that is the same. It is true. So this would form a right triangle. You could put those together to be a right triangle. Okay, so if you look at 5, 8, and 12, we're going to go through the same process. So which one has to be C?
12.
12 has to be C. So 5 squared plus 8 squared equals 12 squared. So 25 plus 64 equals 144. And I believe that together equals 89. And that would not be true. So this is not a right triangle. Does not form a right triangle. Okay, so I want you to try the next two, doing the same process. You're deciding if it makes a right triangle or not. So you'll have to pause your video and go through those. All right, so 9 squared plus 12 squared equals 15 squared. So that would be 81 plus 144 equals 225. So 225 equals 225. So this one is a right triangle. And then on the next one, you have 8 squared plus 10 squared equals 13 squared. So 64 plus 100 equals 169. So 164 equals 169. Not true. So this is not a right triangle. Okay, so for your assignments, you are doing page 140 and 141.